Okay, this is an overview of chapter 5. So it's going to go in two parts. The first part is what you've learned so far. And then the second part is what you're going to finish up for this week. I'm going to put a test up and give you guys a few days to work on it. And then you can just scan it, or I haven't decided yet. Either I'll make it multiple choice for the answers, or you can scan your answers. I haven't figured out what will be easiest yet, but it will be due Friday. Anyway, let's go through the first few sections. It goes in order in your review. I'm just gonna do the review with you so you can understand if the lessons weren't clear for you or the homework wasn't. It says simplify the following polynomials, then arrange in standard form, and while you're at it, classify the polynomial and by degree and terms. So the first one is just not in order. So you're to the 5th power. So you're a quintic, and you did have to combine the last two. So if you're 4 or more terms, you're a polynomial. So this is a quintic polynomial. Okay. The next one, x to the 0 power, is just 1. So these two will cancel. This is actually a 1, so a -1 and a 1, so you're just going to get x. Well, there's one term, and it's to the 1st power. And if you're to the 1st power, you're linear, and you're one term, so you're monomial. The next one, I would FOIL 2 of them and then distribute the last one in. And I'm going to combine it. 7x and a -1x makes a positive 6x. And then when you continue, distribute x to all 3, and then 2 to all 3. You're going to get x cubed plus 6x squared minus 7x minus 2x squared minus 12x plus 14. You're going to get x cubed, and then you're going to have 4x squared minus 19x plus 14. So you're to the 3rd power, so you're cubic, and there's 4 or more terms, so you're a polynomial. The last one, you have to square the last 2 terms. I'm sorry, you have to square the last quantity, which is actually foiling and not just bringing the 2 in here and here. You can't just make it x squared plus 1 because it's actually going to be the distribution of 2 terms. So it's actually x squared plus 1x, which is 2x plus 1. So you're going to get -3x to the 4th. You're going to get -6x cubed. You're going to get -3x squared. You're going to get -x cubed, -2x squared, -x, plus 2x squared, plus 4x plus 2. You're going to end up getting -3x to the 4th minus 7x cubed minus 3x squared. And you can always pause the video or rewind it and slow it up. The answers to this in a clear display are on the classwork section. It's in a PDF with the copy of your notes if you would like it as a printout. Okay, so you're to the 4th power, that means you're quartic, and there's 4 or more, so you're a quartic polynomial. This is a section that a few people had a problem with, or that let me know that they did. So you graph this in your graphing calculator. And when you do, you're going to see a maximum or a minimum. And so really what we care about is the mins and maxes here, because we're talking about increasing and decreasing. So we need to know these x values. I don't know if this is wider or skinnier. It doesn't even matter. All I care about is the maxes and the mins for this section. So you'd go in your calculator to second trace min. Now, if you don't have your graphing calculator, you can go into Google and just type in graphing calculator, and then you can do it yourself on the computer, and you can literally just drag the mouse to where you see minimum, and it should give you the value. So there's a minimum here at -1, -6. I'm only going to put -1 because that's where we stop decreasing. So if you go left to right like a roller coaster, you're decreasing and then you're increasing. So if you start way out here, -infinity, your graph is actually up here. So as you go left to right, you are decreasing until -1, and then you're increasing forever. As x gets bigger, you're increasing forever. So your intervals are -infinity to -1. Oops, we actually hit 1, so it's a bracket. And then you're increasing from -1 to infinity. Here, we are at points that are about -1. It's like -0.97 and a little bit bigger than 5. And then your other point's about 0, 0. So it goes a little something. Oh, shoot. Wait, no, today's Sunday. Sorry. I was thinking I had a Zoom meeting, but that's tomorrow. How's everyone doing? Are you losing track of the days like me? Okay. So here we go, increasing to decreasing to increasing. So we have 3 intervals. So as you go left to right, you are increasing, decreasing, increasing. So your interval for increasing. Now I'm not picky. I think you guys know that. So you could put 0.97, you could put -1, whatever it asks for. Normally you just gotta look at the directions. If it asks the nearest tenth, nearest whole number, you could just gotta do what the directions say. So this is -0.97. So I'll try to be as accurate as possible. So you're increasing from -infinity to -0.97. And then from 0.97 to 0, we just care about the x value. You are decreasing, and then union is a letter U. It's like and. You're joining with the other. And obviously you'd hop back and forth. These two would never be beside each other. You don't decrease and then decrease again. Yeah, we only care about the x values because increasing and decreasing are what your y values are doing. So the y values are covered there. So that's the first few sections. And let's see. The next few pages are from 5.5 and beyond. We'll throw some in there. We will do 7, 8, 9, and 10. It's factoring. So most of us have done factoring. Now, it's tricky because you've never done the difference of 2 perfect cubes. So you look at this and you always ask yourself first and foremost, is there any fat to trim? Is there a GCF? Well, here they both have a 2 and they both have an x that you can take out. And when you remove those, they want you to just not factor, but to factor and solve. So when we solve, we're equal to 0. The zero product property says that we can set each factor equal to 0 and solve, and those are our zeros, our solutions, our intercepts. So if I substitute 0 back in, I will get 0, and if I substitute 2 back in, I will get 0. Another familiar one that you should be able to do is number 10. Do you have 3 terms with a plus in the back? No, you have 3 terms with a minus in the back. So one sign will be plus and one will be minus, but we don't know which one. We do know that we have x squared, so it's going to be x and x. We also have a 2, so it's 2 and 1. I do a guess and check method because it's logically figuring out what would work, and the more you do this, the better you will be at it. You can do a method called slide and divide. And if you want to look up a YouTube video on sliding and dividing factoring, you can, but I try not to show as many tricks as actually trying to figure it out. That will help you in the long run. So factors of 5 are 5 and 1. Here's the thing. I know it's not going to be 5 and 1 because if it was 5, I know in my head I saw that 5 and 2 is 10. And if I put 5 here, 5 and 2, well, maybe it would work. 5 and 2, will that ever give you a positive 3? Yes, if it's a positive 5 and it's a negative 1. So it will be able to be factored, and you don't have to use the quadratic formula. Well, also the hint here is factoring. So does 2x squared? Yep. To negative 2, positive 5? Yep. And 5 times negative 1 is negative 5. So it worked. Then you set each piece equal to 0, and you solve. Done. All right, look over here. That is 4 terms. I mean, you could combine these two, but if there's 4 terms, probably something should go off in your head as, can you group? Can you look at each and say, oh, they have a GCF in each one. And if it's the same GCF now created, then grouping is what you want. If these two weren't the same, you wouldn't use grouping. I'd probably put these together, try to factor, use quadratic formula. But I don't need to. So I see now that I have a GCF in the first and a GCF in the second to create an overall GCF of x minus 3. When I remove the x minus 3 or factor it out, I'm left with an x plus 2. So this is the same thing as this, is the same thing as this. When you set each piece equal to 0 to solve, your answers will be 3 and negative 2. And last one for the first part is the difference of 2 perfect cubes. So there's a pattern to it. If this is plus or minus, it doesn't matter, ignore it for now. What is the cube root of 27? It is 3. What's the cube root of x cubed? It is x. What is the cube root of 125? It is 5. So you put your two numbers there. You square the first number, 3x squared. The whole quantity would be 9x squared. You squared the last number, 25. And the middle term is when you multiply the two middle numbers together, which is 15. If it's minus, you write minus, and then it'd be minus plus plus. And that's just how the pattern goes. Somebody saw, I don't know who, but over time, people did this enough where they realized there was a pattern and somebody wrote it down. So now we've learned it. They want you to solve. Well, you set this piece equal to 0 to solve. You're gonna get 5/3. And if you set this piece equal to 0 and you solve, you're gonna get, you're gonna have to use a quadratic formula. When you do this, I've already done it, I believe you get negative 15 over 18 plus or minus negative square root of 675. You got to break that down. And if this isn't clear enough, you can look at the PDF file where it's a little clearer. And you're going to